What if the last voice from the edge of our solar system was about to go quiet, and the only way to save it was a plan so risky that NASA is scared to try it on the real spacecraft first? Right now, a small group of engineers in California is racing against a machine that is slowly dying 16 billion miles away, with no way to fix it in person and no second chances if they get it wrong. Before we go further, do one thing for me. Tap that like button right now, not at the end, right now, because this story only gets heavier from here, and I want you standing with me when it does. Subscribe if you want to know how it ends. Share this with one person who still remembers watching the sky as a kid. Here's where we start. Somewhere out past every planet you have ever heard of, past the orbit of Pluto, past the edge of the sun's own protective bubble, there is a machine the size of a small car, still awake, still listening, still talking to Earth. It is called Voyager 1, and it has been flying since 1977. Think about that year. No internet, no smartphones. Most homes did not even have a personal computer. And yet, this spacecraft, built with the technology of that era, has been quietly working for 49 years, further from home than anything humans have ever built. Voyager 1 is moving at about 38,000 miles per hour. That is fast enough to cross your entire country in a few minutes. But space is so vast that at this speed, it would still take more than 70,000 years just to reach the next star. It is not going anywhere near a star. It is just going out deeper and deeper into the dark, into a region no spacecraft had ever entered before. In 2012, Voyager 1 crossed a boundary scientists call the heliopause. This is the place where the sun's influence finally fades and the space between stars truly begins. On that day, Voyager 1 became the first human-made object to leave the sun's bubble and enter interstellar space. Not close to it, inside it. Right now, as you are watching this, that spacecraft is drifting through space that belongs to the stars, not to our sun, and it is still sending back information about what that space is actually like. But here is the problem. Voyager 1 was never built to last this long. Its original mission was supposed to end after 4 years. It flew past Jupiter, then Saturn, and by all normal expectations, its job was finished by 1981. It just never stopped working. And the team at NASA's Jet Propulsion Laboratory never stopped listening. The reason it is still alive is a source of power called a radioisotope generator. Inside it is a small amount of plutonium, slowly decaying and releasing heat, which gets turned into electricity. There is no sunlight strong enough to power solar panels this far out, so this slow radioactive decay is the only thing keeping Voyager 1's systems running. The problem is that this power source cannot be refueled. It cannot be repaired, and it is shrinking every single year, whether anyone likes it or not. At launch, this system produced about 470 watts, roughly enough to run a few household appliances. Today, in 2026, it produces less than half of that, and it will keep dropping. This is not a guess. It is basic physics. The plutonium is decaying at a fixed, unchangeable rate, and there is nothing anyone on Earth can do to slow it down. So for years, the team at NASA has been making painful choices. One by one, they have had to shut down the very instruments that make Voyager 1 valuable, just to keep the spacecraft itself alive. Out of 10 original science instruments, 7 have already gone dark, not because they broke, because there was no longer enough power to run them. This wasn't done in panic. Years ago, scientists and engineers sat down and planned out exactly which instruments would be turned off, and in what order, to squeeze out the maximum amount of discovery before the lights finally went out for good. It was, in a very real sense, a plan for how a machine should slowly die with dignity, giving everything it could before the end. That plan was holding steady. Then, on February 27th, 2026, something happened that nobody expected. Engineers sent a routine command, a small adjustment to rotate the spacecraft slightly, something that had been done safely hundreds of times before. But this time, when the command executed, the power levels on Voyager 1 dropped. Not by a huge amount, but on a spacecraft where every fraction of a watt is already accounted for, any unexpected drop is not a small inconvenience. It is an emergency. Here is why. Voyager 1 has a built-in safety system from the 1970s. If the spacecraft ever tries to draw more power than its generator can supply, the system takes over automatically. It does not ask permission. It does not wait for a decision from Earth. It starts shutting things down on its own immediately to protect the spacecraft from damage. Now remember, Voyager 1 is so far away that a radio signal moving at the speed of light, the fastest anything can travel in the entire universe, still takes 23 hours just to reach it, and another 23 hours for a reply to come back. That means if this automatic safety system ever kicks in, the team on Earth will not even find out until nearly a full day after it already started making decisions on its own. Decisions that might shut down the wrong system, in the wrong order, possibly even damaging something that can never be restored. The engineers were not willing to wait and hope that didn't happen. so they made a hard call. On April 17th, 2026, they sent a command to permanently shut down one of Voyager 1's last two working science instruments, something called the Low Energy Charged Particle Detector. This device had been running, almost without a single break, since the spacecraft launched in 1977. It had spent 49 years measuring particles and cosmic rays, both inside our solar system and out in interstellar space. Nothing else in existence could replace what it was doing, because nothing else was out there. One of the mission's leaders described the decision with quiet honesty. Shutting down a working instrument is never anyone's preference, he said, but it was the best option they had left. That sentence says a lot. Not a good option. The best of the bad ones. Voyager 1 now has only 2 working science instruments left out of the original 10. But here's the part that should give you chills. When the engineers shut down that instrument, they didn't shut everything connected to it off completely. They left one tiny motor running, using less than half a watt of power, almost nothing, but deliberate. A small, quiet decision that hints at what they are planning next. That plan has a name. They call it the Big Bang. If you're starting to feel the tension building here, that's exactly the point, because what comes next is the riskiest thing NASA has ever attempted on this spacecraft. Before we go there, hit subscribe now, because I promise you the next part of this story is the kind you'll want to tell someone else about later. And if you're new here, welcome. You picked a good day to show up. So what exactly is the Big Bang? For years, the engineering team has been asking a hard question. When you have already shut down almost everything you can shut down, when you have already turned off heaters for parts that no longer seem essential, when you've already rewritten software using programming languages, most people alive today have never even heard of what else is left. Where does the next bit of saved power even come from? The answer they landed on was surprising. Instead of turning off more things, they decided to change how power moves through the spacecraft itself. Voyager 1's electrical system was designed in the early 1970s, using the engineering standards of that time. Back then, efficiency mattered less because the spacecraft had hundreds of extra watts to spare. But today, with barely half its original power left, some of those old, slightly wasteful pathways are no longer something they can afford. If the team can reroute how electricity flows across the spacecraft, they might be able to recover valuable extra power. Power that could be enough to bring a dead instrument back to life. Here's the terrifying part. This cannot be done gradually. It cannot be done one small step at a time. Because if you change one power pathway and leave the others as they are, even for a moment, the temporary imbalance could trigger that same automatic safety, a shutdown they are desperately trying to avoid. So the entire power system has to be reorganized all at once. A single, simultaneous all-or-nothing switch, attempted on hardware older than most of the people working on it, from a distance so vast that if something goes wrong, nobody will know for almost 2 full days. Because this is so dangerous, the team refused to try it on Voyager 1 first. Instead, they are testing it on its twin, Voyager 2, a spacecraft launched just 16 days earlier in 1977, but which took a different path through the solar system. Voyager 2 is slightly closer to Earth and has a bit more power remaining, making it a marginally safer place to experiment with something this new. If the test on Voyager 2 goes well this summer, only then will the team attempt the same procedure on Voyager 1, no earlier than July of 2026. And if it works, if every calculation holds and every old, tired component responds the way it's supposed to, there's a real chance that instrument they shut down in April could power back on. One of the scientists connected to that instrument put it simply. He said they were holding out hope to power it back up, to keep learning whatever surprises are still waiting out there in that distant region of space. Whatever surprises are still waiting. That phrase matters more than it sounds. Because Voyager 1 has a long history of finding things nobody predicted. Since 2017, one of Voyager 1's remaining instruments has been picking up something strange. A constant, steady hum in the plasma of interstellar space. Not a burst, not a one-time event. A continuous signal that has now been detected across hundreds of millions of miles, present year after year, and still not fully explained. Scientists have 2 competing theories about what's causing it. Choosing between them could reshape how we understand the space between stars. But answering that question needs more data, the exact kind of data that comes from combining multiple instruments working together. With the particle detector now shut off, that ability has been lost, unless the Big Bang succeeds in bringing it back. This is not just a curiosity for scientists in a lab. The region between the stars, the interstellar medium, shapes the size and strength of the sun's protective bubble around our entire solar system. That bubble is what shields Earth and every planet around us from the harshest radiation in the galaxy. If that region is more turbulent or structured than we ever realized, then the shield protecting our own planet may be far less stable than we assumed. Understanding it isn't just about a distant machine, it's about understanding the environment that allowed life on Earth to exist in the first place. And here's the part that makes this all feel so urgent. There is no replacement mission ready to take over. Scientists have proposed sending a new, modern spacecraft specifically designed to study interstellar space. But as of today, that mission exists only on paper, no funding, no launch date. And even under the most aggressive plan possible, a new spacecraft would still take about 25 years just to reach the same boundary Voyager 1 already crossed back in 2012. That means if Voyager 1 goes silent before a replacement is ready, there will be a gap of decades, real years where humanity has no direct information at all from interstellar space. No new data, no new answers. Just silence, until something new finally arrives out there, a quarter of a century from now. This is what the Big Bang is really trying to prevent. Not just saving one machine, trying to protect the only real-time window we have ever had into the space beyond our own sun's reach, for as many more years as it is physically possible to keep it open. There's one more date worth marking on your calendar. On November 18th, 2026, Voyager 1 will reach a distance from Earth so extreme that light itself, the fastest thing in existence, will take a full 24 hours just to travel between the spacecraft and home. One light day. Try to picture that. A signal sent this morning wouldn't arrive until tomorrow morning, and whatever Voyager 1 sends back in response wouldn't reach Earth until the day after that. A single question and a single answer, start to finish, will take 2 full days. Now imagine trying to run an emergency repair procedure under those conditions. Every single check, every command, every tiny adjustment costs days, not minutes, before the team even knows if it worked. And yet, this isn't the first time this exact team has stared down a crisis like this and found a way through. In late 2023, Voyager 1 suddenly began sending back garbled, unreadable data. For months, nobody could understand what the spacecraft was even saying anymore. Eventually, engineers traced the problem to a single damaged memory chip, worn down after decades of exposure to cosmic radiation. The fix required rewriting the spacecraft's own software from Earth, splitting the code into pieces and storing it in different working sections of memory, essentially performing surgery on a computer nearly 50 years old, using a communication delay of almost 2 full days for every single test. It took months. It worked. Then in 2024, an attempt to activate a heater accidentally triggered Voyager 1's automatic safety system, forcing the spacecraft to switch to a backup radio transmitter that had not been used since 1981. 43 years of silence on that particular system. And the team had to bring it back to life using knowledge that almost nobody currently working on the mission had ever personally used before. They did it anyway. Communication was restored. Every single time, the story has been the same. A problem that looked unsolvable, followed by a team that refused to give up until they found a way. If this story is pulling you in the way it's pulling me in, do something small for me before we finish. Comment one word, just one, hope, if you want Voyager 1 to make it through this. I'm genuinely curious how many of us are rooting for a 50-year-old machine we'll never actually see. So here is where things stand right now. Sometime this summer, the Big Bang procedure will be tested on Voyager 2. If it succeeds, the same risky, all-at-once power reconfiguration will be attempted on Voyager 1 in July. If that works too, there's a real chance the shutdown instrument comes back online, and Voyager 1 keeps listening to the space between the stars for a little while longer. If it fails, the spacecraft may lose power even faster than expected, pushing its final silence closer than anyone wanted. Either way, by the time Voyager 1 reaches that 1 light day milestone in November, we will likely already know which outcome happened. Here's what gets me the most about this whole story. This spacecraft was never built to last 49 years. It was never built to discover a mysterious, unexplained hum in the dark. It was never built to challenge what scientists thought they understood about the boundary of our own solar system. It was built by people using paper calculations and slide rules, and somehow, against every reasonable expectation, it is still out there, still working, still trying to tell us something. Right now, in a building in Pasadena, a small team of engineers is refusing to let that end quietly. They are attempting the most complicated power maneuver ever tried on a machine floating 16 billion miles from home, communicating across a gap where every message takes almost 2 full days just to arrive. And they left a tiny half-watt motor running, quietly, patiently, just in case hope turns out to be worth the risk. The signal is still coming. Faint, but real, crossing 16 billion miles of empty space to reach the largest listening dishes we have ever built on Earth. If you want to know whether the Big Bang works, whether that instrument comes back to life, whether Voyager 1 keeps speaking to us a little longer, subscribe now and turn on notifications, because when that answer finally arrives, I want you to hear it here first. 49 years ago, a small piece of human curiosity left this planet and never looked back. It is still out there. It is still listening. And for now, against every odd stacked in front of it, it is still talking to us.